Question 1. Using the mean value theorem, find where the instantaneous rate of change is equivalent to the average rate of change. Using the equation y equals 2x squared minus 6x plus 3 on the interval 2, -1. So to begin, you're going to plug in the 2 into the equation, and that's going to give you -1. And then you're going to do the same thing with the -1 on the interval, plug it into the equation, and that's going to give you 11. And then you're going to do the mean value theorem. So you're going to use these two numbers on top and then these two on the bottom. 11 minus -1 is 12. -1 minus 2 is -3. So 12 over -3 gives you -4. And then you're going to find the derivative of the original equation, which is going to give you y prime equals 4x minus 6. And you're going to use the mean value theorem value, and you're going to set it equal to the derivative. And that's going to give you 4x equals 2, which simplifies to x equals 1/2. So that's the instantaneous rate of change is equal to the average rate of change. Question 2. Find the intervals on which the function f of x equals x to the third plus 4x squared minus 3x plus 7 is decreasing and increasing, and find any relative extremes. So to begin, you're going to find the derivative of f of x, and that is going to be 3x squared plus 8x minus 3. And that simplifies to this, which is 3x minus 1 times x plus 3. And then that gives you x equals 1/3 and x equals -3. And then you're going to make this chart. So -infinity to 3, because these are critical values, the critical points, and they're equal to 0. And then you have to find a range. So in this range, -infinity to -3. So a negative times a negative equals a positive. So you're going to put a plus sign. And I use -4 as the value. And then for the next one, I use 0. And that's a negative times a positive gives you a negative. And then on the last one, it's 2 positives equal positive because I used 1. So that gives you f of x is increasing on -infinity to 3 and 1/3 to infinity, because f of x is positive. And f of x is decreasing on -3 to 1/3 because f prime of x is negative. And to answer the last question, find any relative extremes. So you have to look at these. So f is increasing at -infinity to -3, then it's decreasing, so at -3 to 1/3. So at x equals 3, there's a max. And f is decreasing at -3 to 1/3, then increasing at 1/3 to infinity. So at x equals 1/3, another critical point, there's a minimum. And on the last question, find the absolute max value find the absolute max value and the absolute minimum value of the function on the given interval, and you have to check all the candidates. So the equation given is f of x equals x to the third plus 2x squared plus x minus 5 on the interval -2, 2. So to begin, you're going to find the derivative of f of x. So f prime of x is going to equal 3x squared plus 4x plus 1. And that simplifies. You have to factor. So then that's 3x plus 1, and then x plus 1. And x is equal to negative 1/3 if you do that, equal to 0, and then that's x equals negative 1. So those are the critical points. And you have to find all the candidates. So that's where this comes in, the interval. So those are the endpoints. So you also have to put those in to find the absolute max and the minimum. So you have to do f of negative 2, f of negative 1, f of negative 1/3, and f of 2. And then you plug all of these in to the original equation. So when you do f of negative 2, you plug it in, it gives you negative 7. And then when you do f of negative 1 into the original equation, it gives you negative 5. And then when you do f of negative 1/3 into the equation, it gives you negative 5.148. And then when you do 2 into the original, it gives you 13. And to find the absolute minimum, you have to find the lowest number, which in this case is negative 7. So at f of negative 2, that's the absolute minimum. So at x equals negative 2. And then to find the max, the absolute max, you have to find the highest number. In this case, it would be 13. So at x equals 2, that would be the absolute max.